Okay, this is sample problem 9.4. Ammonia, NH3, is a trigonal pyramidal molecule with HNH bond angles of about 107 degrees. Describe the formation of the three equivalent NH bonds and explain the angles between them. So let's begin by drawing the Lewis structure for ammonia. And we know the angles are 107 degrees. So here's what we're going to use to explain this. Let's first draw out for nitrogen the valence shell. Central atom, right? The focus on this is the central atom. That's valence bond theory. Nitrogen has 5 valence electrons, so it's 2s2, 2p3. Okay? Now, here's what we're going to argue. This is the theory that we use. In a sense, it's an ad hoc theory. What we do is we say, how do we explain the observations? The observations are, there are 3 equivalent bonds, meaning each nitrogen-hydrogen bond is the same length and the same bond enthalpy. They're identical. That means there have to be 3 identical orbitals used by the nitrogen atom to form bonds to the hydrogens. So you might quickly say, oh, here's your answer. You got the 2s right there. That's the lone pair. And then you got the 2 p's here. And each of those forms a bond to one of the hydrogens. The problem with that is that if that happened, each bond would be 90 degrees apart because those would be 2p orbitals, and 2p orbitals are 90 degrees apart. But the angle is 107 degrees. What happens is the more orbitals you mix, the angle will change. And it turns out if you mix 4 orbitals together, you get an angle of around 109.5 degrees. Okay? So if you combine 2 orbitals, you end up with an angle of 180. If you combine 3 orbitals, you get an angle of 120. And if you combine 4 orbitals, you get 109.5. Now look at that angle, 107. That's much closer to 109.5 than it is to 120 or 180. So that tells us we must be combining 4 orbitals. Well, which 4 orbitals are they? It's got to be these 4 right here. These are the orbitals that are in the valence shell. So we're going to claim that all 4 of these are getting mixed together. If you get an angle of 109.5 or near it, it's got to be 4 orbitals. If you get 120, it's 3, and if you get 2, it's 180. Or if you get 180, it's 2 orbitals. So the mixing or hybridization when we mix these 4 orbitals together, what you do is you name the first one, which is an s. Don't worry about whether it's a 2s or 3s or 4s. We just call it s. And then the next type of orbital that's being added is the p, and then you count how many there are. There's 1, 2, 3. So 3 there. That's the notation of hybridization. You name the types of orbitals that are being hybridized or added together, combined if you want to use that term. And then you indicate how many of them are getting combined. Now s is always going to be just s, because there's never more than one s in a given shell. But for the p's, you can have up to 3. For the d's, you can have up to 5, right? But for the p's, you can have up to 3. In this case, it's 3. And again, the logic is, if you get 107, that's close to 109.5, so it must be 4 orbitals. So that means all 4 of these orbitals are mixing. Now, what happens is, when you get the orbitals mixing, the orbitals you get out, the number of orbitals you get out is equal to the number that get added together. So if you're adding 4 orbitals together, you're going to get 4 new orbitals, and they're all called sp3. But there's going to be 4 of them. These are equivalent orbitals. Okay? So now what you do is you say, okay, let's put our electrons in here. Okay, how many electrons do we have? We have 5. So what I'm going to do is I'm going to use the Hund's rule. 1, 2, 3, 4. Got one more. Where's it going to go? Well, it's got to go in one of these. I'll pick the one on the left. And there you go. So now here's what we end up with. 4 equivalent orbitals, one of which has 2 electrons. That would be the lone pair. And then 3 of which have 1 electron. These could be used to form bonds. Okay? So that's essentially what happens. So when we think of the nitrogen, essentially these orbitals, I'm going to draw them like these. There's 1, and this is an sp3. One of them has 2 electrons. That's your lone pair. The second one comes out here. This is also sp3. It only has 1 electron, but the hydrogen has 1 electron. So you get 1 from each. So there you go, you're set. Another one comes over here. That's an sp3. Overlaps with the hydrogen. Again, 2 electrons, 1 from each atom. And then going into the board, into the plane of the drawing, there's your 4th one, sp3. Again, we have 2 electrons, 1 from the hydrogen, 1 from these orbitals here. Now, you might say, well, why is that any better than what we did up at the top? And again, the angles. These would be 90 degrees apart. These would be somewhere around 109 degrees apart. The data suggests it's 107. That's much closer to 109, so it must be something like this. There must be some combination or hybridization going on which would explain these angles.